Hello everyone, today we are here to implement the mathematical function factorial by using the Verilog SDL language. First of all, what is factorial? Factorial is a product of every real positive integer which is equal to or less than that number. And I assume that all of you guys know the basic of Verilog syntax and basic of Verilog coding styles. Okay, now we have to start our code part. Yeah, here is the code. First of all, we define module as usual. Module name is fact, in which two things are defined, in and facto. The next line was parameter width. Parameter is a keyword which is used in Verilog for defining constant for module instantiation. And width is a variable name, and here we define it equals to 4. And the third line is input. Input and output both length are depend on the constant parameter width equals to 4. Here the input length is width minus 1 to 0 means 4, and the output is width into 11 minus 1 to 0 means 4. Width means you have to represent in decimal 0 to 15. If you calculate 15 factorial by manually or by using the calculator, and then that number convert into binary, you know that the length of that number in binary is equals it's 44 or less than 44. Okay. The next part is, here we define the integer I. Why we are defining integer I? Because in the factorial code, what is basic function of a factorial? Inside it is multiplication. For multiplication we need at least two number. One number is that what is factorial we are defining here in the next line, but other is integer I. And then we define the always block. Always block begin. We just initially define that factor equals to 1. Okay, initially it is 1 and I integer is 0. Okay, and then while if I less than if the input is greater than our defining I equals to 0, then this loop function will begin. I is I plus 1, then I is incremented by 1, it's 0 to 1, then factor equals to factor star I, means factor is already defined as 1 and I is all time increment. Okay, whenever I in is greater than I, then this loop will be working as usual. So here we end of this begin, and here we end of this begin, and this is end module of defining the module of end. Then we go to the test bench of this module. Here is the test bench. Okay, the first line was clear. It's defining the module name. Parameter reg wire is always clear as usual. We will be going to before. Here we instantiate fact by using the keyword UUT, and we all know that how to instantiate. Here we initial and begin the values of we have only one variable in input. That's here we defining some values to the input by using initial, begin and end module. Here I will take the values like 0, 2, 4, 16, 7, 10, 11. I am not using the values beyond the 15 because my width is 4. That's why I am not using the value behind the 15. Now first of all we save that, and first we elaborate the design. Yeah, here we only noted the mux and the assign block, because in the code we do not use any type of structural modeling, we do not use any type of gate, we only use the always block, begin, assigning, and that's why our schematic is look like this. Okay, now we have to run this simulation and observe the corresponding outputs. Yeah, here is the corresponding outputs. First of all we convert the radix into unsigned decimal, due to which we have clearly observed the respective output. Yeah, we observed that 0 factorial is equals to 1, 2 factorial is equals to 2, 4 factorial equals to 24, 6 factorial equals to 720, and 7 equals to 5040, and so on. Here is the width. Any variable which is defined by the parameter which was also mentioned, which will also come in the training simulations. Okay, thanks for watching.